Losses x under a policy are exponential mean 10. For each loss, the claim payment y is equal to the amount of the loss in excess of a deductible d. Calculate variance of y. So losses are exponential with mean 10, so therefore they will have the PDF 1 over 10 e minus x over 10, x greater than 0. Y is the payout, and the payout we know is loss minus deductible if loss is greater than deductible, and otherwise it's 0. And variance of y is needed, for which we will find e of y and e of y square. So e of y is the integral of y against the PDF, and y is x minus d when d is when x is greater than d. So x starts from d all the way up to infinity. Yeah, x greater than d, that is the same as saying x between d and infinity. And y is x minus d in that part. And f of x is 1 over 10 e minus x by 10. And now we know our shortcut for the x plus k, e minus ax dx. In this case, k is negative d. This 1/10 can be just pulled out. And a is negative 1/10. A is the coefficient of x. And this is our shortcut. So we substitute. So this is the 1/10 that we pull out from here. And then here we use our shortcut. X plus k means x minus, okay, I didn't write it correctly. This is x plus k. Okay, so x plus k means x minus d. E to the ax means e to the negative x by 10. And divided by a, and a was negative 1/10. And here we have e to the ax, which is e to the negative x by 10, divided by a square, which is negative 1 over 10 whole square, from d to infinity. And now when you substitute infinity, this is e to the negative infinity, this is e to the negative infinity. Now any term which has e to the negative infinity will go to 0 no matter what that term is multiplied with. In everything that we encounter, the terms that are possibly multiplied are polynomial terms, and the 0 that comes from e to the negative infinity always dominates whatever the polynomial gets, even if the polynomial is blowing to infinity. And the e to the negative infinity is going to 0. This e to the negative infinity 0 is going to dominate, and it's going to zero out the whole thing. So that's why this part is 0, this part is 0 when we substitute infinity. And then when you substitute d for the lower limit, the x minus d becomes d minus d, so that's also 0. And now this becomes plus, remember, and the lower limit is subtracted, so minus minus means plus. And this be e to the negative d by 10, lower limit is d, divided by 1 by 100. And this simplifies to 10 e to the negative d by 10. So that's e of y. So e of y squared. Similarly, we integrate y squared against f of x. Y squared means x minus d whole square from d to infinity. And now here, we don't have our shortcut. The shortcut doesn't apply here. So here we use our integration by parts, and I'll just quickly go over the way I do it. I have this as my first function, x minus d whole squared. My first function in an exponential and a polynomial situation, the first function is always a polynomial. So I have the polynomial, and my formula is you write the first function as it is. So x minus d squared is written as it is, times the integral of the second function. The integral of this whole thing, the 1 over 10 e minus x over 10, is just negative e negative x over 10, because this is for the exponential part, it's e to the negative x over 10 over negative 1 over 10, and then that cancels with this 10, leaving just negative e negative x by 10. So first function, which is x minus d squared, times integral of second, which is negative e minus x by 10, And then I put in the limits d to infinity. So maybe I should also put that line over here. Okay. And then minus sign, integral sign, and so that's in the formula for the integration by parts, and negative sign and the integral sign. And then you repeat the integral of second, which was negative e negative x over 10. So you basically repeat this one over here times derivative of the first. So you take the derivative of the first function, the derivative of this by power rule is 2 times x minus t. So 2 times x minus t. And now once we have here, so first let's put in the limits. The first one is already integrated and its limits are d to infinity. So when you put in infinity, this is e to the negative infinity. So that's going to zero out the whole thing. And then for the lower limit, when you put in d, this is d minus t, that's going to zero out the whole thing again. So this integral, when you put in the limits, both the upper and lower limits are zero. So we write this zero over here. And then here, negative, negative becomes plus, and I pull the 2 out. And then what's left inside is I've just written this x minus d first and the e to the negative x by 10 second. And now this is our shortcut that we know. And the shortcut, remember, is just e to the x plus k e ax over a minus e ax over a square. So x plus k means x minus d e to the ax divided by a. A is negative 1/10 minus e ax over a square, going from d to infinity. So once again, when you put in the upper limit infinity, this is e negative infinity, e negative infinity, they're both zero. And when you put in the lower limit, when you put in d here, it's d minus d, which is zero. And so only this term will contribute. It becomes plus because the lower limit is negative. So negative, negative is plus. E to the negative d by 10, substitute d for x divided by negative 1 by 10 whole square, and this 2 was already out. So this simplifies to 2, this 2 and this denominator simplify to 200. And we have e to the negative d by 10. So that was e of y squared. So the variance would be e, so and e of y is 10 e negative d by 10. So variance of y is e of y squared minus ey whole square. So e of y squared is this, and ey was 10 e negative d by 10. And now when I square this, the 10 squared is 100. And when I square e to the negative d by 10, it's e to the negative 2d by 10. And then I factor out 100 from these two terms. So I'm left with 2 here. So 2e negative d by 10 minus, and here the 100 is being factored out, and the 2 over 10 simplifies to 1 over 5. And this one is choice D.